This is a rocket science. The core principle of Newton's third law. At its simplest level, a rocket is a machine that exploits Newton's third law of motion. For every action, there's an equal and opposing reaction. Unlike an airplane, which pushes against the surrounding air to create lift, a rocket carries its own working fluid or propellant. By throwing mass out of the back at extremely high speeds, the rocket itself is pushed forward. The action is high pressure exhaust gases accelerating out of the nozzle. The reaction, an upward force called thrust. Now, the rocket equation, in rocketry you cannot simply use F equals ma under Newton's equation, simply because mass is constantly changing as fuel is burned. To calculate how much speed a rocket can gain, we can use the Tsiolkovsky rocket equation. I've probably just butchered that name, by the way, but well, here we are. Delta V equals V E ln of m sub 0 over mf, where delta V is the rocket total change in velocity, VE is how fast gas leaves the engine, MO is the initial mass, rocket plus fuel, MF is the final mass, the rocket when the fuel is gone, so rocket minus the fuel load. Because of the natural logarithm, to double the speed, you don't just double the fuel. You must increase exponentially. This is why rockets are mostly made of fuel tanks. How rocket engines work. Most rockets use chemical propulsion, where fuel and an oxidizer react in a combustion chamber. The combustion chamber is a high pressure continuous explosion area. Now the Laval nozzle, this is the hourglass shaped bell at the bottom. It pinches the gas to the speed of sound at the throat and then expands it to supersonic speeds at the exit. The specific impulse, ISP, this is the miles per gallon of rocket science. It measures how efficiently an engine uses its propellant. The anatomy of a rocket. Engineers group rocket parts into four main systems. Structural systems, the skin and the frame made of lightweight materials like aluminium or titanium. And number two, propulsion system, accounts for approximately 90% of total mass, includes tanks, pumps and engines. Now number three, a guidance system, the brain, the computers and sensors that keep the rocket on its trajectory. Then four, the physical payload system, the actual reason for the mission, satellites, astronauts, probes, etc. Reaching orbit isn't going up. A common misconception is that rockets just go up to reach space. Space is about 100 kilometers away, but to stay there you must go sideways, extremely fast. Orbital velocity, to stay in low Earth orbit, a rocket must travel at roughly 7.8 kilometers per second. And the gravity turn. Shortly after liftoff, the rocket begins to tilt. This uses the Earth's gravity to help steer the rocket horizontally, saving fuel. Now, on this note, I believe that in Newton's original work, I believe it was Newton and not Galileo, he had a picture of what would happen if a cannonball was fired. And at some point, the cannonball would just leave the influence of Earth's local gravitational field, if you will, and continuously orbit around the Earth. I don't know if it was Newton that first did this, or Galileo. I think it was Newton, as he gave it as an example, as like a cannon firing a cannonball, and trajectories that was calculated and where it would be to just to leave the Earth's atmosphere altogether. And this is an essence behind what we were talking about here in Newton's laws and rocket science. And above the nozzle thing, which you would have seen at the bottom of the rockets, they kind of like pinch the fuel as it's coming out. But anyway, that's a little rocket science lecture. I hope you enjoyed. Please do like and subscribe.